Alright, I'm going to start this video out, as I usually do, with a look at Chuck Penson's excellent book, HeathKit Test Equipment Products, which has a chapter for the things that didn't say HeathKit on them, namely the Malmstat Enke series of instrumentation laboratory series. So this was something that HeathKit did kind of on the side, mostly in the 60s and 70s, early 70s I think, for educational institutions. And Malmstat and Enke were apparently two people who were involved with setting this program up. And the majority of the products that HeathKit made in this series were pre-assembled at HeathKit's factory. And instead of saying HeathKit on them, they said HeathBuilt. And they were very similar to HeathKit's designs, but they had some differences. For example, one thing I've noticed on them over the years when I've looked at them is that where HeathKit would use adhesive rubber feet on the bottoms of test equipment, the Malmstat Enke things had riveted on plastic feet. So maybe a notch up a little bit in the quality department. These are, after all, supposed to be going into, college and university and technical school laboratories. So maybe built just a slightly higher standard in some areas. But otherwise, they're very HeathKit-like. The cases are pretty much identical to the way HeathKit products did them. They often use the same knobs and other things, and the internal circuit design isn't substantially different. And there were actually a few products that were available both as HeathKits and under the HeathKit name and as pre-assembled products in this series. There was some overlap. Anyway, so I've just, for the heck of it, landed a handful of products from this series, some of the more basic ones. But before I get into that, I'm just going to give a quick flip through this chapter. For example, they had the EU, that's the basic prefix for this series, the EU-13A. It was a universal experimental chassis. So a little chassis and some parts, and you could wire them up and do different things with them according to the course that you were taking. And then a special experimental chassis, which had some more stuff on it. I actually used something similar to this when I was in my high school laboratory in Germany. It was an American product. I forget who put it out, but it wasn't this one. But it was very similar, except you had to build your own chassis, fold the sheet metal, and make cutouts in the sheet metal, drill holes. It was even more basic, but similar in the idea that you'd be building up various things on that chassis. And vacuum tubes are still a thing in these, although some transistors are in there. So they had a universal power supply, the EUW, and the W in HeathKit products means pre-assembled at the factory instead of as a kit. Now again, most of these are EUW period. There's no just EU version of many of them. But of course these don't have it because you're supposed to build these things as a project board. So the EUW-15 is a universal power supply. The EUW-16 is a voltage reference source, so very low current but fairly high precision voltages over a fairly wide span. The EUW-17 is a transistorized power supply, not regulated, but better than, very highly filtered and reasonably well controlled. The EUW-18 laboratory meter. It's just a meter in a box. And you could hook it up in various ways on a laboratory setup. There was an operational amplifier, the EUW-19, that came in A and B versions, where it had essentially op-amps. They were not based on integrated circuits. The EUA-19-2, a polarography module, It was the first of a series of increasingly complex and arcane scientific instruments. The EUW-19-4, an operational amplifier stabilizer. Various versions of the EU-20A, so these were not really kits, but they weren't apparently wired at the factory either. I'm not clear on that. It doesn't say here. But basically a servo chart recorder. And there's a whole bunch of other stuff. A recording pH meter that would go on the back of another piece of equipment. A pH test box. A log linear current module that I think went with the same product. A VTVM, very similar to a HeathKit VTVM of the same era. A 400 kilohertz single trace DC oscilloscope. And as is noted in the book here, the EUP26 is a pre-assembled volt ohm meter. They call it an analyzer here. They had their own multimeter. That's HeathKit had their own multimeter of similar capabilities called the MM1. I've done a video on that. But instead they bought one from their sister company, Weston. Both HeathKit and Weston were owned by the Daystrom Corporation at that time. And as I've shown in some of my other videos, during the early 70s, HeathKit produced several Weston products in their own HeathKit version, but keeping the circuitry the same. Oh boy, there's more stuff. A sine square wave generator, a resistor substitution box, a capacitor substitution box, a decade resistance box, a high voltage power supply, low voltage power supply, another high voltage power supply. These were all considerably different from the things HeathKit was offering at that time. But some of these are very close to the, for example, this one. I have the HeathKit version of this one. And in the increasingly arcane realm, a 15 megahertz dual trace DC oscilloscope. It's the same thing as a HeathKit IO105. A voltage reference, a voltage to current module for this thing, a function generator, very different from the HeathKit function generators, an analog to digital designer, basically a glorified breadboard in a modular style. Universal digital instrument, the first HeathKit product to ever use a digital readout of any kind. It had a frequency counter, a totalizer, a digital voltmeter, a ratio meter, a time interval meter, a period meter, voltage integrator, all sorts of stuff on it. They had the demonstration servo meter, which is something you'd put in front of a big wall-sized meter scale. It was actually a photo reproduction of the scale from HeathKit's VTVMs of that period. And then they would sit on the table in front of it, have a great big pointer that would swing back and forth so somebody giving a lecture could illustrate it in a way students in the classroom could see it. A high gain oscilloscope, and another high gain oscilloscope that replaced this first one. And that's the end of that series. So, quite a few things. The one that's going to be the subject of my video today is the most basic of everything. I'm starting with the easy one. It's the EUW-18, the laboratory meter, made from 1963 to 1973, so for 10 years. Cost $22, and it was just a simple current meter in a box, but it came with 4 banana plug assemblies that, even though this was pre-wired, the user or the person buying it would wire precision resistors onto the 4 banana plugs that were included, so you could plug them in to use as shunts, thereby getting different current ranges. So using the meter itself is only a 1 milliamp full-scale meter with a resistance of 50 ohms. If you use the shunts, you could get a 1.5 milliamp range, or a 5 amp range, a 15 amp range, or a 50 amp range. And all the resistors are essentially 1%. Okay, here's the artifact as received from eBay. I bought the set of 3. I bought the voltage reference product and the transistorized power supply and this, all from a seller in Beaverton, Oregon, which, as many people know, is a hive of U.S. high technology companies, including Tektronix, for example. They were all fairly clean. This is the roughest one. It actually has some scratches on the meter, but it's not too bad. All of the HeathBuilt or Malmstat Enke products had this kind of off-white side panels or chassis colors, and then the face plates would be this odd greenish color. I consider it Soviet airplane cockpit interior color. That's what it reminds me of. Not a bad looking thing, but you can see that it says HeathBuilt. EUW-18 laboratory meter. And it says right on the meter that it's a 1 milliamp meter, 50 ohms. Now I've already removed the screws on the bottom, but there are the plastic feet with the rivets in them, instead of the stick-on, bump-on feet that Heathkit normally used on the regular Heathkit products. And of course it has exactly what you expect inside: the meter movement and some bus bar wire, very low resistance, going directly to the banana terminals. And it's interesting, this is one of the places where there's a difference between this series and the regular Heathkit series. In the Heathkit series, for something of this same shape, they would have just had a folded over edge on one of the sheet metal pieces to put these speed nuts on them. But on here, probably to give it a little cleaner look, they actually have a separate piece of aluminum that has the folded over flanges for the speed nuts, and it's held in place by 2 of the screws that secure the meter. So, nothing here to see, folks. Move along, move along. It still has the regular, almost regular label on the back. It does say Heath instead of Heathkit, but it's really the same kind of label. And they have a quality control, I think that's a quality control stamp on the back. So one thing this did not come with is all of the shunts that you need to have in order to use it to its full capability according to the original Heathkit specification. So here are the 4 dual banana plugs I purchased. These are the Pomona brand model 1330. There are suffixes that can go on the ends of there. It's like 1330 dash something. Dash 0 means you get the black ones. Dash 1 I think means the red ones, and so on. And you can get these with either the ability to stick a wire in there and turn a set screw to lock the wires in place, or you can get ones that have little solder lugs sticking out the side, and you can solder wires or components onto them. So these allow just going in between your banana plug wires and the meter, and then have the resistor hanging off the side. Here are all the little set screws that are included. Okay, I got those things from DigiKey, and I also bought all these things from DigiKey. The Precision, if you will, they're only 1%, nothing too dramatic, but they're the same tolerance that Heathkit specified for the original parts, so they should be pretty comparable. I was able to get the 12.4s it should be 12.5, but that's well within the specification. It should be just fine, and I was able to get the 100 ohms no problem, and I was able to get the this is the other brand. It doesn't say what their value is. I was able to get 7.15, and that was because I couldn't find a 3.57 ohm from anybody. The others are standard values, so I am going to get that by paralleling a couple of 7.15s, and I'll get close enough. So let's see, 12.4, 100, 3.7. Okay, this resistor here must be the 1.02 ohm part. So I'm going to get busy installing those on the banana plugs. So for these two resistors I have in parallel, in order to get 3.7 or 3.57 ohms, I've opted to just twist the leads together rather than solder them, because I'd have to solder them so close to the body of the leads. Well, actually there would be a way around that, but when you solder up close to a resistor, you can sometimes permanently change the resistance a little bit. So I thought, well, I'll just do it without soldering here, and hopefully have the best possible resistance situation. Okay, all those are made. Resistors are on there. And on the back side, I've put labels on them. Go down in the recesses there. So this is for a 50 milliamp full scale on the meter, and it's a 1.02 ohm resistor. Similarly for these other ones. And I've got the meter itself cleaned up. Just went over it with alcohol and changed the corroded screws on the sides, but used the originals on the bottom. They weren't too bad. Alright, I've got my test set up here. I have my power supply set to 1 volt just to have a little excitation for the current. And the plus side of that's coming out and going into my Fluke digital meter, multimeter in the milliamp mode, DC milliamps that is, come out of there and go into the plus of the HeathBuilt decade resistance box, currently set to about 700 ohms. Let's see, I think everything else is turned down. Yeah, just I'm going to turn up to 900 initially, and then it comes out of there and it goes into the laboratory meter and comes out of there and goes back to the power supply. So just to be safe, so I don't prang this thing, I'm going to crank it up to a high value, or higher value anyway, just in case something isn't the way I expect. I won't ding the meter. Okay, let's turn this guy on, and I get a bit of a reading. Let's take it down, so I'm back down to this here. Alright, now I have 900 ohms, and it's a little bit too much, so I reduce it, and that's too much. So I'm going to increase the next order, and that's really, I can't quite do it there, so I need to have a bit more resistance here. Okay, so this guy is reading full scale. The value here is not important. That's just to change all the other resistances in the loop until it results in 1 milliamp. And my meter says it's basically 1 milliamp, certainly within the specified tolerance of this meter. So that's working well. By increasing the resistance, I can get other values in there, so it's certainly working, no problem. Now, what if I wanted to go higher than that? What if I wanted to go to 1.5 milliamps? Well, I could go through my pile of shunts here and find the one that's for 1.5 milliamps and plug that in up on top. And I should see a drop. Yep. Because now some of the current is shunting through the resistor that's on the other side of this plug. So now I have to decrease the resistance a bit. So that's pretty close to it now, and now I'm reading on the 15 scale, so 1.5 milliamps. And the meter says we're pretty close to that. Again, within tolerance of the meter. What if I wanted to go up to 5 milliamps instead? Okay, I can unplug this. Okay, now I have that shunt plugged in. Okay, so now I'm looking for 5 milliamps, so I'm back on the bottom scale, and that's representing 5 milliamps. And it's a little looser. Some of that's the tolerance of the shunt, but it's still in the ballpark. Getting pretty close there. Now we've got the 15 milliamp shunt in here. So once again we're showing 15 milliamps on here. And it's a bit further off. It's 16 milliamps on here. Well, I can't adjust my decade box quite enough to get exactly 50 milliamps on the meter per this fourth shunt, but I'm pretty close to it. And it is showing 51 milliamps up there. So, again, it's not an incredibly precise meter, and it's old, but it is functional. There's the beauty shunt. I was able to find some kind of manual documentation for all three of the instruments I bought of this series, and I was able to find a full manual, a scan of a full manual, I should say, for the voltage reference, and I was able to find a schematic and a calibration sheet for the power supply. This thing I couldn't find anything except the Orange County Amateur Radio Club put out a sheet by Bob Eckweiler, ham radio guy and also a big HeathKit collector. And it's an exceptionally good report on this product. He does note that it's HeathBuilt and that it's the Malmstott Enke Instrumentation Lab series. Also, according to Chuck Penson's book and this, the same instruments, or at least some of them, were also part of a Berkeley Physics Lab product line, but they were, I don't think they were different instruments, they were just used in both of those educational series. So it's got an introduction. In the early 60s, HeathKit began designing and selling educational kits. Products like the Basic Electricity Course EK1, I have a video on that and its associated tester/meter. The two-part Basic Radio Course, the Basic Transistor Course, the How to Understand and Use educational products such as how to understand and use your VTVM, your oscilloscope, your signal generator, etc. HeathKit also expanded their educational products to support high schools and universities with the Heath Berkeley Physics Laboratory and the Malmstott Enke Instrumentation Lab. and it has pictures on those. This is the equipment you would get with the Berkeley one, and here's the instrumentation you would get with the Malmstadt-Enke series. So you also get a bunch of tools and cables, various instruments. So a little different, but similar. So he goes on and gives more history on this, and goes through the Malmstadt-Enke series, just the same things that are in Chuck Penson's book. Then he starts getting into the EUW-18 laboratory meter, and describes in some detail the theory of operation, which is of course very simple, but it's all about the shunts that you may or may not use with it. And he shows how you do the math in case you don't already know, presents the formulas, and stipulates what the resistor values are that were provided by HeathBuilt for the different shunts. So for example, if you wanted to use the meter on a signal or a current up to 1.5 milliamps, you needed a 100 ohm shunt. If you wanted it to go up to 5 milliamps, you needed a 12.5 ohm shunt, and so on. 50 milliamps required a 1.02 ohm shunt. And then this is the type of dual banana plug that they furnished, 4 of, one to go with each of the shunt resistors. And then a diagram from HeathBuilt's manual, apparently, showing how you would bring in your wires that the current is going through, and then introduce the banana plug shunt into the banana jacks on the top of the meter, and they would have that resistor on it. So most of the current would go through the resistor, and what didn't go through the resistor would go through the meter. Anyway, so this was of particular interest to me in verifying what the shunts were, so I could reproduce those from my collection.